I'll help you. But they've been here the whole time, so all right, session's being recorded. Autofocus lock, full screen. Okay, I think this will help you, especially if you're more of a visual learner. Let's go back to this page right here, which the three of us have already reviewed this today. So watch my video. We've already reviewed this, okay, earlier today. But there are two restrictions, and we, on the day that we learned this, we didn't know anything about graphs, we didn't know anything about shifts, we didn't know anything about V's or quadratics or U's or shooting stars. We didn't know any of that when we took these notes right here. Y'all agree with me on that? So what we had to do is look at the formula and decide that, okay, you can't have a 0 in the bottom and you can't have a negative under the square root. Remember this stuff. All right, I want to show you, and you don't really have to write this down because it's not going to fit nice and neat on your worksheet, so I'm going to put it on a sticky note. But let's look at this. All right, the formula for this equation is y equals the square root of x subtract 5 and then plus 2. Now, let's pretend like we're not graphing it. Let's pretend like we're doing our restrictions. Let me put the restrictions up so we can see it at the same time. All right, let's pretend like we're doing the restrictions. Pretend like you can't see the graph. No 0 in the bottom. Well, does this have a denominator? Nope, so that doesn't apply. Number 2, no negative under the square root. We do have a square root, and this stuff cannot be negative. The stuff under, which is x minus 5, cannot be negative. Now, if you go a little bit further, the worksheet tells you exactly what to do. If the radicals in the top set it greater than or equal to 0. In other words, this has to be positive. So we would have set it greater than or equal to 0, and we would have said x has to be greater than or equal to 5. That's what we have done in the past when we wanted to talk about restrictions. That's just a review. I'm giving you that for free. Well, now we can get the restrictions from looking at the graph, because if you pick this up and look at our graph, lo and behold, where does our graph start? 5, and it goes forever to the right. The restrictions in the algebraic portion coordinate with the restrictions in the graph. So we said for number 2, this is number 2. For number 2, we said your x's have to be greater than or equal to 5. Well, when you graphed it, the x's were greater than or equal to 5. So that makes sense. This is the algebra way to look at this problem, and this is the graphical way to look at the problem. Notice the domain. What did we say the domain was? 5 to infinity. That's exactly what this says, because if you think about, we've talked about interval notation. If you were to graph this, it would be a closed circle at 5 and shaded to the right. So as an interval, it would be bracket 5, comma, infinity. And that's exactly what the graph told us. This is looking at it graphically. This is looking at it algebraically. But we're getting the same answers. And I want to look at one more because number 4 fits this really, 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 really nicely. So let me get my sticky note on number 4. All right, so for number 4, let me just copy down the equation. It was 1 over x plus 3 quantity squared plus 1. All right, I look at my restrictions. Remember, there's 2 restrictions. No 0 in the bottom. Well, do I have a denominator for number 4? Yes, I do, right? So this cannot equal 0. X plus 3 cannot equal 0, because if it equals 0, it would have 0 in the denominator, and that's undefined. So x cannot equal negative 3. This is what we would have said last week when we didn't know about the graph. Well, let's look at what we just did. What x did we say this volcano is never going to cross? Negative 3. The reason that it cannot cross negative 3 is because that would give us a 0 in the denominator. And that's why the graph has an asymptote at -3 because it cannot cross there. It would be undefined. Now that's the little food for thought. That ties together, if you think about it. Let me look at the very first page of our packet. So the very first page of our packet, we were talking about domain and range on all of these problems. That was day 1. And then the very last day of this packet, we're talking about graphing. And graphing is tied directly to what we did the first day when we were talking about the domain and range and the restrictions and stuff. Does that make sense? That's something we'll try to talk about more next week. You got to think about that a little bit. But the connection is neat because you're saying, oh, yeah, the restriction that we got in algebra is the same restriction on the graph. So that makes sense. All right.